Hello, Mr. Math Geometry kids. Let's talk about some special triangles. Here we have a square, and we got a little pink diagonal here. And that square, we're going to talk about some measurements. Now, of course, I can probably, I'm certain that I can count the squares, but let's talk about the side here. The side length is S. That's not a 5, that's an S. So if this side length is S, then what is this side length going to be? Well, of course, that's also going to be S. And so what is the hypotenuse going to be? We'll call this HYP. You know that the hypotenuse is equal to A squared plus B squared. Excuse me, the hypotenuse squared is equal to A squared plus B squared. So if that's the case, then how do we find the hypotenuse? Well, A squared A is S, so we square that. We add it to the square of the other side because they're both the same length, aren't they? And so that equals a hypotenuse squared. So S squared plus S squared, well, that's pretty much 2S squared, isn't it? And so the hypotenuse squared is equal to 2S squared. And so now we just find the square root of both sides. And we say the hypotenuse is equal to the square root of 2S squared, but that equals the square root of 2 times the square root of S squared. And of course the square root of S squared is equal to S. And so we have sorry about that. We have S times the square root of 2. Okay, so the hypotenuse is equal to S square root of 2. And so now we have the general form for every single triangle, which is, well, wait a minute, what kind of triangle is this? Are we talking about? We're talking about a right isosceles triangle. So every right isosceles triangle, it's a right triangle and it's isosceles. Well, if it's an isosceles triangle, these two have to be 45 and 45. Because they have to be the same, and since this is already 90, these two have to add up to 90. So they have to be 45 and 45. So another name for a right isosceles triangle is a 45, 45, 90. This is one of our special triangles, a 45, 45, 90 triangle. And the side lengths, or the ratio of side to hypotenuse, is S square root of 2. The hypotenuse is always going to be S times the square root of 2. There's a story about Pythagoras tried to find a way to make a triangle, a right isosceles triangle, with the hypotenuse a whole number. And he couldn't do it, and he went crazy trying to figure that out. Because there was no way to do that, because the hypotenuse is always going to be the side times the square root of 2. So if the side is a whole number, the hypotenuse cannot be a whole number. So unfortunately, Pythagoras kind of went nuts trying to figure out how to do that, and it can't be done. So anyway, here we have the side square root of 2. Okay, so this is how you do it. So if you have a triangle, for example, running out of room here. So if I have a right triangle or a right isosceles triangle, and I say that the side, these two are congruent, and I say that this is 5 and this is 5, which it has to be. Well, what is this? Well, that's pretty easy. It's 5 times the square root of 2. And if I use my calculator, I can come up with a decimal approximation of that. But the important thing to remember is this is 5 times the square root of 2. What if I have, this is even trickier, what if I have the hypotenuse is 8, okay? Well, we want to know what is the side. What is each one of these sides equal to? Well, the 8 is equal to side times the square root of 2. And so if we want to know what the side is, we have to divide both sides by the square root of 2. And so side equals 8 divided by the square root of 2. Well, I cannot leave a radical or square root sign in my denominator. So I got to multiply this times the square root of 2 over the square root of 2, which equals 8 times the square root of 2. What's the square root of 2 times the square root of 2? That equals 2. And so 8 over 2 is equal to 4. So we're talking 4 times the square root of 2. And if I went a little quickly through that, and I hope that that doesn't confuse you, we did some basic numbers there in algebra, but that's what the side length would be, 4 times the square root of 2. Okay? So, and having said that, let's talk about the next one here. And that next one is, let's start with an equilateral triangle. Okay. Now, as you know, in an equilateral triangle, the side lengths are 60, or excuse me, the angles are 60, 60, and 60. So if we put this purple line in here, this is the height. But it's also, because of the type of triangle we have here, it's also the angle bisector. And it's the bisector of this opposite side here. So this side is congruent to this side. So let's just suppose that the side length of this is 2s, 2s, and 2s, because it's an equilateral triangle. So what is the measure of each one of these angles? Well, it's going to be 30. And this is going to be 90. And so we have our second type of special triangle, and that's a 30, 60, 90 special triangle. So we get rid of 1/2 of this, okay? And we're just looking now at this triangle right over here. So recreating that triangle, we can say this is the triangle, okay? So we've got a right triangle. We've got this side is now, this is the hypotenuse is 2s. You say, again, it doesn't matter what s is equal to. S can be equal to 5 or 10 or whatever it wants to be, okay? But this is half of the side down here. So this is going to be s. Okay, so now all we need to do is find this missing side. Well, once again, a squared plus b squared equals c squared. So this is c is equal to 2s, a is equal to s, and b is equal to, we don't know what yet, we haven't figured it out. So we got b squared here, so if I subtract a squared from both sides, we know that b squared is equal to c squared minus a squared. Well, what is c squared? Well, let's take a look here. C squared is equal to 2s quantity squared. Okay? And a squared is equal to, whoops, that's supposed to be a minus a squared, and sorry about that. Oh boy, oh boy, oh boy. Get rid of all that stuff there, and there we go. Minus s squared, because a is just equal to s. Okay? So 2s squared, remember, the reason I put the parentheses is because we have to square the whole thing. So 2 squared is 4, s squared is s squared, and subtract s squared, and what do we get? We get 3s squared. And so b squared equals 3s squared. So once again, I take the square root of both sides, and I get b equals the square root of 3 times the square root of s squared. Well, that equals s times the square root of 3. And so b is equal to s times the square root of 3. Now, it doesn't matter what s is equal to. S can be equal to 5, it can be equal to 20, it can be equal to 9. It doesn't matter. So here's how we do that. We say, okay, I've got a triangle here, which is a special 30, 60, 90 triangle, okay? And so there's my 30, 60, 90 triangle. And okay, that might be hard to see, so I'll switch to black. So there's my 30, 60, 90 triangle. This side is 14. And so what is this side and what is this side? Well, it's pretty easy. If this side is 14, this has to be half of that. That's 7. And this has to be 7 times the square root of 3. That's how that works, because all you need is one dimension, and you can find the other two dimensions just by using the formulas. Once again, let's try one more here. This is a little trickier. And this time, I've got a 30, 60 triangle, 30, 60, 90 triangle, and this side is equal to, let's say, 5. And so what is this side and what is this side? Well, if this side is 5, that equals 5 equals s times the square root of 3, doesn't it? And so if I want to know what s is equal to, I divide both sides by the square root of 3. And once again, I can't have a radical on the bottom. So 5 divided by the square root of 3 times the square root of 3 over square root of 3 equals 5 times the square root of 3 all over 3. So s is equal to 5 square root of 3 over 3. And how much is this one equal to? This is twice as much as the s. This is 2s. So this is equal to 10 times the square root of 3 over 3. Now, we're going to do some more of these. We're going to review this in class. So if this doesn't make sense to you right away, hang in there. Everything's going to be fine. Now, we're going to try one more thing. It's kind of cool here. How do you find the area of a regular polygon? I'm emphasizing it's a regular polygon. That means that all the sides and all the angles in this polygon are congruent. For example, watch this magic. See that? We have a hexagon. Now, a hexagon is kind of a unique figure because a hexagon has 1, 2, 3, 4, 5, 6 equilateral triangles. Okay, so these are all equilateral triangles. And so if this, like the last time, we said that this is equal to 2s, this is 2s, this is 2s, 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 and 2s. So what is a perimeter? There are 6 of those. So I've got 12s equals a perimeter. Okay, and this, now we know that this is the height of the triangle, but when we're talking about an equilateral or a regular polygon, this is also the apothem, A-P-O-T-H-E-M, apothem. That's what that is. Apothem just means I go from the center, perpendicular line from the center to the flat side. Okay, so that's my apothem. And so I've got 12 sides. This is my perimeter. Okay, my apothem is the same as the height. So what's the area of this triangle? It's 1/2 base times height. How many of these triangles do I have? 1, 2, 3, 4, 5, 6 of them. So the area of the whole polygon here is 6 times 1/2 times base times height. Well, as I said, the height is the same as the apothem. Base, how much is the base? 2 times s, right? And I've got 6 of those, so I go 6 times 2s times 1/2. That's the area of my whole perimeter. And so 1/2, 12s times A. Well, what does 12s equal to? That's equal to my perimeter. So the area is 1/2 times the perimeter times the apothem. You say, well, what does that all mean? Well, every regular polygon has the same formula for the area, even if it's not an equilateral triangle. If we have a, for example, we have a hexagon or a octagon, for example, it doesn't matter. The area is always going to be 1/2 times the perimeter times the apothem. That A means apothem. Okay, so that's all we have for you now, and we'll talk more about these in class. Thank you so much.